The mitogen-activated protein kinase pathway, usually referred to as the MAP kinase pathway, is a key signaling pathway by which the cell responds to external stimuli. There are a number of such MAP kinase pathways which involve different proteins at each step, but they share some common features. Here, I'll describe the generic pathway. Each MAP kinase pathway starts with the activation of a guanine nucleotide exchange factor, or GEF. In this example, we show the activation of a GEF by the T-cell adapter protein, LAT, which links the ligand binding to the T-cell receptor with MAP kinase pathways. GEF proteins activate small g proteins by exchanging GDP bound to the G protein for GTP. In the GTP bound state, the G protein is active and can activate other proteins. In the MAP kinase pathway, the protein activated by the small g protein is a MAP kinase, or MAP KKK. The activated MAP KKK now phosphorylates a second kinase, a MAP kinase, or MAP KK. MAP KK is a dual-function kinase, able to phosphorylate both tyrosine and serine or threonine residues on its target. The MAP kinase phosphorylates and activates a third kinase, MAP kinase, or MAPK. The activated MAP kinase now migrates to the nucleus, where it is able to activate transcription factors.